All right, now we are going. So, hello everyone, it's Mr. Barden here. Over a bit about synthesizers and how to implement them just on a basic level using Tone and P5. Before I jump into that though, if you enjoy the topic, you learned something, feel free to do like, subscribe, YouTube, blah, 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 blah. It is helpful, all the things. Okay, um, so let's get into it. So basically, what I'm going to go over is just what a synthesizer is and why you might want to implement one, and then how to do that. Later on, probably most likely in the next video, I'll go over how to program sequences so you can have your synthesizer do specific melodies and actually play melodic lines. But for right now, it's just going to be, here's a synthesizer, let's make it make a sound. All right, that's going to be kind of the goal for today. Going on from there. One quick thing, if you look real quick down in the description below, there's a link to this sketch that I'll be making over the course of the video, as well as some online textbook material for this course that I teach that's going to go over a lot of what I talk about here, and all the reference material for tone, so that should be very helpful for you. So just go through all of that. Okay, so let's just jump right into it now. So what a synthesizer is just something that generates tone. It synthesizes the tone. So that's what we're going to be implementing there. You may have seen these in different kinds of keyboards and other instruments, things like that. But what's kind of important to know is up until this point, if you've been kind of going through these videos in order or you've been taking the course along with me, we've only worked with playing back sound files. The computer is not generating the audio, it is just playing it back and then altering it at that point. But the computer itself is not generating the audio from scratch, and that is what we are going to be doing. So one plus side of this is that you don't have to worry about taking up a bunch of memory space or having to stream a lot of data through the internet when you're implementing this. You don't have to worry about sound files being too big or the wrong format or blah blah blah. You're just sending instructions, so that way the computer on the other end is then generating the audio in real time. And that's if you're using this, for an internet application. If you're doing this on your home computer, then obviously your computer will be generating all of this in real time. So how is the computer generating this? Well, I've got this chapter right here. I'm just going to go through just a little bit of it. We'll get in through some notes, and actual code bits in a while. But basically, what's happening is the computer is working with numbers, essentially generating a series of numbers in a specific pattern. And then we can use different, adjust different settings in order to change what that pattern is. So, hold on, my stream is acting up. There we go. Okay, says it's going now. But anyways, we can continue this pattern of numbers and alter them however we need to make different sounds. I have on the screen right now kind of the four most basic patterns. We get the sine wave, which is a general, curved up and down. Square wave, which jumps between high and low values. Triangle wave, we just move straight to the up and the high and low values, like the sine wave, but no curve. And to achieve with this software computer synthesizer is replicating a hardware synthesizer. Again, like those keyboards and things I mentioned earlier. Maybe you've seen the kind with all the knobs and the cables that you patch around on it. What those are doing is those are generating electrical voltages in the same patterns, essentially. So this would represent, changes in electrical voltage over time. We are going to be doing this with numbers. So how we get that into sound is just like we were playing back the sound files. We're converting the numbers into electricity that then our speakers use to push the air to make the sound. It's the same thing, only the computer is generating the numbers itself instead of playing back the file that has all of those. That's just a general, summation of it all. We can give our synthesizer different pitch, as well as adjusting the timbre of it, how it sounds. and things like that. There's some other stuff we're going to get into probably in another video. Actually, I may break this into two videos and then go into sequences. We'll see how we go. Okay, so let's get into making a synth. Oop, there we go. Nice, like that, and then you can either do this in setup or preload. There's it kind of works both ways. I tend to do a lot of my audio setup in the preload function. That way it's ready to go before we even get into setup and things like that. Kind of like when you load in an audio file, sometimes a lot of times you may have both of those going on in a sketch. So I just put it all in one spot, get it ready to go before we even get into setup. So I'm going to do this in preload, but there's technically no rule that says you have to. So synth is going to be a new tone.synth. And then again, this will be the sketch already has the tone library included. I'm not going to go over that in this video. I've gone over that a lot. Okay, so we have this right here. And then we also need to say dot to destination. All right, just so we can actually hear this. Just like the player's object, we can kind of open this up and specify some parameters. In fact, I've got some of this right here. There we are. And we're just kind of using this JSON notation right here in order to specify kind of what we need in order to make the sound. So I'm actually just going to replicate this. So using that JSON notation, we can go in and say oscillator, and then we're going to break that into a subgroup of type and then give it the value. So I'm just going to say oscillator type sine. There we are. So now we're going to generate a sine wave whenever we play this. So you may have already looked and seen some other in my first button. So I usually do this in setup, but A4 is going to be it's going to equal create button. And we're going to play the note A4. So I'm going to put that as the label. A4 dot position. It's going to be, I'm just going to put it there, and A4 dot mouse pressed. So whatever happens when we click on this button, we'll say play A4. It's going to be the function. So I just got to go down and actually make this function. Function play A4. So now this is going to be the trigger to play back the synthesizer. Just like we had with the sound files, whenever we had to tell it to start playing the sound file, we have to tell it to trigger the sound. So to do that, we say synth.trigger attack release. It's a very long method, but this just tells the synthesizer to start and stop the note. Again, you can kind of see that right here, and we just have to tell it what note to play and for how long. And this is just the number of seconds. So we want note A4, and we want it to go for, I'm going to do 0.5 seconds. So now if I run this, we see our button on the screen. Again, I've done all of this stuff in another video, so that's why I'm not going through it right now. I'm focusing on the synthesizer. And I'm going to click this in just a second, so hopefully this won't be too loud, but I'm warning you now just in case you're listening on headphones. So here I go. All right, it didn't seem too loud. It just went doo, about right there. And that is generating a note at the pitch A4 for 0.5 seconds. Now, if you've done any kind of audio synthesis before, you may know that you don't have to refer to these by a note. You could say the frequency of the pitch. which in this case happens to be 440. Maybe I wanted it to be, 460. I rerun this, and it's slightly higher. So you can get really specific with the notes. You don't have to stick with the musical note names like on a full keyboard. But for the context of this class, I find that using the note names tends to be helpful. But for other things, you can do all kinds of controlling. You can set that in a variable, change it, do all kinds of math, make some really interesting stuff. I'm going to put this back at A4 for now. We'll go there. Up here where I set this as a sine, you can change this between any of those 4 values. So maybe I want a square wave instead. I rerun this, and this is going to be the same pitch, but it's going to sound different. Then here's triangle. And that's kind of like the sine wave, but a little bit different. And sawtooth. Yeah, so those are the 4 main ones. I'm going to go back to sine for this video, but you can swap that up to wherever. And again, you could just do that with a command of, synth.oscillator.type equals one of those values. In fact, in the textbook, I've got a sketch right here where we do this. So let's just look at this real quick. So this was made by one of my colleagues in the program, but so basically what this will do is this will switch between the 4 different types, and you can kind of see the differences there, but you can press the keyboard to play a scale. There we are, and that's sine, but we click on square. So on. But basically all we're doing is we've made the default synthesizer, we made all the buttons, we're telling it to put all the text, adjust the background color. I'm saying if we press the key, it's gonna play one note, and so on for all of the number rows. And we get down to engines right here that get triggered whenever we click a button. And all these do is set the synth.oscillator.type to sine, changes the color so we can have visual indicator, and also just changes this text so we can see it below as well. And that's really it. My stream may have just blipped out for a second. You can't see it because my me is in the way, but I get notifications and stuff, and it's like OBS has got angry at me. But most of this stuff is built off of the object oscillator. So I'll just open this up in a new tab. And all an oscillator does is it generates those numbers between the high and low values. Again, as you go between the high and low values, it tells the speakers to move back and forth, which pushes the air. It oscillates back and forth, and however fast we want to do it. But all this does is it generates the sound for forever. It goes and goes and goes. We have to start applying what's called an envelope to the sound. Where are we at envelope? Somewhere in here. I guess I could search. There we are, envelope. And what this will do is apply changes to the volume of that oscillator over time. Because again, the way oscillators work is they just go. As long as they exist and they're on, the sound is going forever and ever and ever until you shut it off or it's the end of the universe. But we can have a specific envelope here that says how long it takes the sound to start, changes in the duration, how long the sound goes on for, and how long it takes to fade out. That's the attack, decay, sustain, and release. And we can apply that to the envelope, or to the oscillator, I'm sorry. And we can adjust this in real time by, changing these values. But in order to make our life just a little bit easier, we have these instruments here. I'm going to pull up Synth, the one we used. that already does this for us. So you can see Synth takes the Omni oscillator object. Let me look at that one just to see. Okay, so the Omni oscillator just does all of the main, it can do everything that tone can do. So um, and that's again just the initial frequency and the type, stuff like that. Um, so it can do a lot of different stuff that we'll get into in a bit. Um, let's be type, yeah. So this can do all of these type. Um, I wonder, can I do? Okay. Okay, that's not a right type, but FM fine. Sine. So you can get additional types other than those four. I don't know if that's an update or I was just misinformed, but I thought this was built off of the oscillator object, not the Omni oscillator. So there's a whole bunch of different types you can play around with here. Um, there's the whole list of them on top of the sine, square, triangle, and sawtooth that I've already mentioned. So you can get some really interesting sounds and adjust the various parameters. I'm going to encourage you to play around with that on your own, and if you make something cool, put it down in the comments so we can see that. But what the synth does, just to get back on track, I got a little distracted there, is it takes that oscillator and it automatically applies an envelope, and then it sends it to whatever output we want. So we don't have to worry about making it all of these different things. It automatically combines it. So to wrap this up, because I think I'm kind of getting towards the end, I'm going to make 2 more buttons for this, and I'm going to set up an effect, because everything we've done so far with sound file playback can still be done with this, the synthesizers. This is just a different audio source. All of the manipulation can still be a thing. So A4, let's go with A4. Let's go with E5 and B5. Let's go B4. There we are. Okay. So I'm just gonna copy this. Basically, to make some new buttons, A4, B4, 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 E5, 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 and I'll just scoot these over in a row. So this will be 200. Oop, not that one. 200, 300, and instead of play A4, this will be play B4, play E5, like so. And now I just have to make these functions. And again, copy and paste is your best friend because it's a lot of stuff here. So B4, B4, we got E5 and E5. So again, I've just copy and pasted and changed some slight values, so now I can play 3 notes with my synthesizer. Again, I'm just doing some real basic examples, but you could make a clickable synthesizer keyboard by doing this. Wouldn't take a ton of effort at all, and then you could change up what your buttons look like if you got into doing some of that kind of appearance and CSS stuff. That's a bit beyond the scope of this class. This is just more about the how to do it, less on the how to make it pretty. Okay, so I've got that set up right there. I liked the pulse width, just because I thought that sounded kind of fun, so I'll swap that there. Okay, so I've made this. Let's make an effect. Let's say reverb, and a ping pong delay. Okay. So boop boop boop. I'm gonna just go in here and reverb equals a new Tone.js reverb. Oh, capital C here. And I think that for JC reverb we just need the room size. Yeah. So let's just say 0.6. And the boom 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 ping pong is going to be a new tone dot ping pong delay. And let's say double checking that I got this right. Ping pong delay. Well, okay, we need the speed and the amount. So let's say 250 millis. Let's just do actually 100 milliseconds and have that. Okay, so I've made all of those effects, and I'm going to go into my setup function, and I'm just going to synth.chain them. So now we'll send the audio signal through multiple things in order. So let's do the just for the sake of the video, let's do the ping pong, and then reverb, and then the speakers. The order can affect how different things sound, but for this one, I'm just picking that. So now, what did I goof? Ah, there we go. There we are. So now we should hear same synthesizer, but we've started to apply effects to it. So just by adding some reverb and some delay, I just went click, 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 and that made a much more interesting thing. A little bit more of a fun sound source right there. And that's, I think, where I want to leave it off today. Is just we've made a synthesizer. There are several kinds of synthesizers. If you just look under that instrument tab, and so you can play around. There's, again, the Omni oscillator kind of incorporates a lot of these other kinds of oscillators, but we have some that, do different kinds of modulations, some that do different voices, some that sound like metallic instruments, some that sound like percussion instruments or do noise or strings, and a bunch of different stuff. So it depends on the context of what you need, but they all generally follow this kind of format. So if you want a specific thing, like maybe you wanted something that's being kind of plucked using, it is using that, that's what I thought. But you just got to specify, anything you might need here. So this one you can just say, trigger it, play these, and it does all the stuff. Some of this, when to play it, things like that, we'll get into when we get into sequences, but that's basically just saying, now plus this amount of time. So we haven't told it how to make any methods yet any melodies. And in order to do that, we'll have to just set up the clock so it's able to keep track and monitor time so it knows when to play the melodies. That'll be the core of the next video. But again, once we've made our synthesizer, set up what we want it to sound like, you can adjust little sub-parameters for each of these oscillator types if you look in the documentation. You can apply effects to it, just like audio playback. You can trigger it with mouse clicks, buttons, keyboard, anything we've already done, you can set it up the same way. I actually didn't even use mouse pressed at all in this function. And so on. And it's that, I think it's relatively simple. If you just set it up and set up a trigger for when to play a specific note and for how long. You can control all of these with variables or sliders as well. So maybe, heck, you know what? I'll do one more thing to wrap it out. It's kind of a bonus. Pitch slide. Oop. All right, this is a bonus. I'm doing this on the fly, but otherwise I'm done. So if you don't care about my bonus, you can wrap it out, and I'll see you all next time I see you. But if you think this might be fun, I'm going off on tangents. I've had way too much coffee today. So this will be where I wrap it out by seeing if I can adjust the pitch with all of this. So, do pitch slide, and how about you save? There we go. And note, and the note pitch itself. Okay. All right. Oh. Slide. I'm gonna make this into a new slider with a range of 20 to, we're gonna say 10,000 hertz. We'll start it at 200. I'll move 1 hertz at a time. Pitch slide dot position. It's going to be right there. Okay, so now this is where I need to look and see some things. So we have in here let's just go all the way to the top. Properties. Frequency is the signal. So what we should be able to do is go into the draw function and say synth dot frequency dot value equals pitch. Actually, yeah, okay, we don't even need this variable up here. Equals pitch slide dot value. This may not work. We will see. And then I'm just gonna I'll leave these there, but we'll change this. So now we instead have synth dot frequency dot value. This may or may not work. It does work. I'm going to stop that now because that's getting grating. But to wrap this out, basically all I did, I'll restore this what it was for all the YouTube video, but I'll keep this in a little commented section. But basically all it's doing is we've made our slider here. It has a range of really low to kind of high. But basically, we're just saying whatever the value of that slider is, we're going to stick, and apply that to the frequency of the synthesizer. So as we change that, that's updating. However, we aren't triggering the note until we click the button. So if you change the slider, click the button, it'll play one note, change it somewhere else, it clicked another, just like we saw. And I kept everything else the same. So that's going to wrap it up from me today. Officially, I'm calling it there. Everyone have a great rest of your day. If you learned something, like, comment, subscribe, YouTube, blah, 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 blah. You know the drill.